So on 21, I think most people were okay with this number 1. Um, Again, because the digits for Tiger, Lance, and Serena were in tens, then you could do one-digit numbers. So I let 1 and 2 be Tiger Woods, 3, 4, and 5 be Lance Armstrong, and then 6 through 9 and 0 be Serena. But I do know that other people did like 0, 1, 2, 3, 4, okay, 5, 6, 7, 8, 9. And you could even do two-digit numbers as long as 20% of your ballot values went to Tiger Woods and 30% went to Lance, and so on. It's okay. Now, this was a problem where they said, boom, look at 5 boxes. Boom, look at 5 boxes. So look at 5 boxes, look at 5 boxes, look at 5 boxes. So my trial consists of picking 5 boxes, or 5 one-digit numbers in this case. And then here you want to say if you ignore anything, and so I typically at that point say if repeats are okay, or if I need to ignore repeats, and if there are any digits that I need to ignore. You kind of don't really have to necessarily digits are okay, but if there were any that you need to ignore, put that there. All right, so then your response is what you are getting from one trial. Yes, ma'am. You know, this is questionable too about saying repeats are okay. I like to have you put repeats are okay because that keeps you in the mindset of thinking about it. Because if you don't always think about it, then you're more likely to forget if you have to ignore it or not. So let's just always kind of think about if they're okay or not. All right, so let's actually take a look at how I had done this. So each trial was look at 5 numbers, look at 5 numbers, look at 5 numbers, look at 5 numbers. And then I was determining, it said, find the probability of getting a complete set. So my response on one trial was yes or no to me getting that complete set. So that's how I described that here. I said the response variable is yes or no to getting a complete set of pictures. Okay? Now this statistic, you don't have to describe, I know I did in the notes, you don't have to describe the whole, this is the proportion of times that you get yes or whatever. You can just give me the number. So when I did that, there were 10 out of 20 times that I got a complete set. I do know if you used 0, 1 for Tiger and 2, 3, 4 for Lance, so I got 60% of the times. Anybody get that? Anybody do that one? Okay, and was it 60? Yeah. Okay, so if you did the 0, 1. Now, if you did something else or started somewhere else, I don't necessarily know those. Anybody do anything else on those? Wondering where you were? Okay. All right, so then according to my simulation, every time I pick 5 boxes, I have about a 50% chance of getting a complete set of cards. Okay, next, number 2. This was the same representation of cereal boxes, so let the number, each digit represent and let the numbers be is probably the same. Use the second random number table, but this one said go until you get a Tiger Woods. So this was not boom, look at 5, boom, look at 5, boom, look at 5. This was go until. So here on the second one, I would look at digits until I got a Tiger Woods. That's the end of a trial. And the response is how many boxes I had to look at to achieve that goal of Tiger Woods. First time was 3, and then you go here, he wasn't until the 8th box on my second trial, and so on. So when I averaged those, I got 4.9, which it is an average, so I can check, about how many boxes I need to look at. Who did 0, 1, and then what was your number? 3.4? Okay, cool. All right, so fairly close to that. All right, so that means that how we ended this was saying, according to my simulation, I expect to have about 4.9 boxes, or have to look at about 4.9 boxes on average to get a Tiger Woods. I don't know if I have to say on average and about. I think either one. I like putting that on average in there. Yes, ma'am. Okay, good question. For this response variable, this is what is your response per trial. So that response variable is not the average. The response is this thing, yes or no, or this number here. So the response variable is the number of boxes you looked at to get a Tiger Woods, not average. The statistic is the average. The statistic is the average. All right, number 3 was another one where you look at a set number of items. You look at 6 multiple choice items, and then that's what you are. That's the length of your trial, looking at 6. I was able to do 1-digit numbers because 80% chance of getting them correct. So I let numbers 1 through 8 equal a correct answer, 9 and 0 equal a wrong answer. So a trial consists of 6 1-digit numbers. Repeats are okay. And then my response is yes or no, I got all of them correct. Because the question was, what's the probability you get them all right? So my response was yes or no to getting them all right. It's all right. Okay, so yes or no to getting all 6 questions correct. All right. Now the last one was the most interesting. The thing that made this one different is that they changed the probability of what was happening in the middle of the trial. I mean, during the trial. So this one was interesting because a trial consists of taking driver's tests until you pass. They did have to be 2-digit numbers because the percentage rates of success were 34 and 72. So they did have to be 2 digits. So the trial is picking 2-digit numbers until you pass. Okay, so that's the length. But here's where it gets interesting. You have a different rule for the first driving test than you do for the subsequent driving tests. So here, I wrote down here at the bottom that the first attempt has this particular rule of 0, 1 to 34 being a success. And then you could say, you're not ignoring the other ones, but the other ones are failures, I guess. I probably should have written that 35 to 99 and 0, 0 is a fail. And then, upon failing that first attempt, you then have a different set of rules for the second and the subsequent tests of 0 to 1, of which 73 to 99 and 0, 0 are fail. So, when I come up here, I'm going to zoom in on this real close so you can kind of see exactly how I did that. So the first number was 94, and that pass was 1 to 34. So this is a fail. So the person takes a second test. Second test has a different rule. It has the 1 to 72 pass rate, and that's the number 35. So ding, 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 that's a winner. Done with the trial. And the response is the number of tests you had to take to pass. So in this case, we had to take 2 tests to pass. Okay? So the next one, first number being 97, is a fail on the first. 40 is a pass in the 1 to 72 rule. You passed. This next one you passed right off the bat. You got a 25, that's a pass, so you passed right off the bat. And this next one is the last one I'll do. It's interesting. Because the first number is not a 1 to 34, so you fail. The second number is not a 1 to 72, so once again, you failed. And then the last one is a 1 to 72, so that's a passer. Your trial is over, and that took you 3 tests. So, when I did 20 trials, I averaged 1.8. And I forgot my last sentence here. So my statistic is the average, and that's 1.8. So according to my simulation, I expect to have to take about 1.8 driver's tests on average to pass. Okay, questions there? Yes, ma'am. No. Now, the next one on page 23 is an actual AP exam question. So I hope that you could do this one. So this is an actual AP question. So what it described is that they pick people who get to come and pick a ticket, and there are 50 winning tickets, but the ticket you get defines how much money you won. And then they will do this each week on a Saturday. So they will continue to draw numbers and have winners. Now they'll do without replacement. So a person cannot, a particular ticket cannot win more than once. It is not drawn more than once. So the numbers will continue to be drawn without replacement until the radio station has given out $300 or more. Then they stop giving out winnings. Okay? So there's a couple of things you could ask about this. You could say, how much do they end up giving on average? It's going to be a little over 300, probably. But in this case, they asked, estimate the number of winners you have each week. Not how much money we give out each week, but how many winners. So I used 2-digit numbers since we have to have 50 coupons. 01 to 05 was defined in the paragraph as winning $200. 06 to 20 was defined in the paragraph as winning $100. And 21 to 50 was defined in the paragraph as winning $50. And I ended up, you ignore repeats. And I also ignore the rest of the numbers because I did not count those as tickets. Okay, so they say pick until $300 has been awarded. That much or more has been awarded. So that's what a trial is. A trial consists of picking tickets until a sum of at least $300 has been given out by the radio station. Then your trial is over. And that response that you are measuring is how many winners there were in that trial. So the response variable is the number of prize winners. Not how much money, but the number of prize winners that week. So it said perform 3 trials. I did 1 per line, but you could have continued. So these were not coupons. The first coupon or ticket was the number 33, which was a $50 winner. The next one was, we'll zoom in a little bit here. The next one was number 47, which was a $50 winner. That's not a ticket. Then number 3 was a $200 winner, so ding, ding, ding. The radio station has now accumulated, handing out $300, so they are finished. And that meant that there were 3 winning tickets in that trial. 3 people won that week. Now you could have continued on that line. I went to the next line. I probably should have said something on that, how I did that. I wonder if I did. Use a random number table below, start at the top left-hand corner. And I should have said, and use 1 line per trial, but I didn't. Okay. All right, so I did the next one. Now, this is interesting. We'll just do this one, and then we'll stop. Those don't count. 42 was a $50 winning. 37 was a $50 winning. 17 was a $100 winning. So I've given out $200 so far. This number here was $50, and so I'm up to $250. So I have to keep going, and then I give out $100. So I actually have topped $300. They gave out $350 that week, but that's okay. They said meets or exceeds, so that stops, and that ends up being 1, 2, 3, 4, 5 winners. Okay? When I did my trial number 3 down here, I had 4 winners, but notice when I did my one down here, there was a repeat ticket that I had to not use. So notice that when I did that. If you continued on the top line, did anybody have repeats? A repeat that you had to ignore? That's interesting. I thought that they would have done that because on the AP exam, I thought they would have kind of manipulated the numbers so that you would have had to demonstrate that you ignored a repeat. So would they have been truly random? No, but they wanted to see that you had to ignore something. So my statistic is that average of 4. If you continued, what average did you get? If you continued on the top line, what was your average? 3 was your average. So according to my simulation, I expect there to be about 4 winners per week on average. Would it be okay for that number to not be a perfectly even number? Could it be 3.6? Yes, because it is an average. Okay. So there's that. Now, we are not going to go up over the warm-up problem because I just want to do that whenever we're just later. It's a number 6 on the AP exam. It's a little bit more involved. So we're not going to go over that right now, but we will at some point because it's an important one to discuss. So let's quiz.